Right now, open your vocab notebooks to the Chapter 8, Lesson 1 vocab. We're still on the same lesson, so you're just going to draw a squiggly line underneath number 3. And then write today's date, March 23rd, 2021, and we're going to start with number 4. Your textbook should be open to page 362. Okay, yes, Smith.
For some reason my shoulder feels like it's burning.
Okay,
And
maybe
it was really hurting when I was putting my stuff away.
maybe it fell asleep or something. Try to just like do that and maybe it'll go away. If it keeps happening, maybe you can see if you can get some ice or something, but I don't know if we can get ice. I didn't think about that. So try to do that and see if it feels better. If not, let me know and maybe you can go get some ice. Okay, so in yesterday's, what we talked about yesterday, we talked about all about what causes day and night. What causes day and night? The Earth's what? Lena?
The Earth's rotation.
The Earth's rotation. That means spinning around the axis. Spinning like this. Not like this. Around another object. But spinning like this. When it's daytime, my face is North America. Where's the sun? It's daytime. My face is North America and it's daytime. Where's the sun? Ethan. In front of me. Now it's nighttime in North America. Where's the sun? Kingston. Behind me. Very good. So that means, does the sun move? Is the sun moving in front of me and then moving behind me? You can show me. No. What is moving? Class.
The Earth.
The Earth. It's spinning. The sun is the air conditioning unit. It's in the back of the room. I'm facing it right now. It's not moving. I'm moving. How long does it take for the Earth to make one rotation? That means spin around one time. So here I'm facing the sun. And now I'm facing the sun again. How long does that take? Zadie?
24 hours.
24 hours. So, my face is North America. The air conditioner in the back of the room is the sun. 12 hours from now, which direction will my face be facing? Colin?
Away from the air conditioner.
So, towards the...
Back.
Towards the
Board.
board. So 12 hours later, I'll be facing away. And what time of day will it be in North America on my face, Colin?
Night.
Nighttime. Good. Now, that is day and night. Today, we're talking about seasons. Do not get them confused, because seasons are caused by something different. This is where people get confused every single year. They start to think of seasons as daytime and daytime as seasons. Zadie, please read on page 362.
I don't have my facial on.
Okay, thank you for being honest with me. Please get it on. Ethan, please read loudly and slowly on page 362. Yeah, you have your facial on. If you need to hold it, that's fine. But loud, loud, loud.
What causes seasons? Not only does Earth rotate around its axis, it always revolves.
Not at always, but
It also revolves around the sun. Revolution is when one object travels around another.
so what's our next word, Ethan?
Revolution.
Revolution. And what is revolution, Ethan?
The revolution is when one object travels around another.
When one object travels around another. Think about those definitions. Are rotation and revolution the same thing? Victoria?
No,
No!
because
What is rotation?
rotation is when you spin around, but you don't spin around an object, you just spin around.
Good. Rotation is when I do this. Bless you. I'm spinning in one place. Revolution is when I go around an object. So right now, I'm going to make a revolution around my podium. Do you see the difference? This is rotation. This is revolution. Rotation is spinning in place. Revolution is when you move around another object. Rotation causes day and night. Revolution causes seasons. Keep reading, Ethan, and tell us a little more about that.
The path, a reveling
Not a reveling, but a,
revolving.
there you go.
Object takes is its orbit.
So what's our next word, Ethan?
Orbit.
Orbit. And what is an orbit?
To have a revolving object. Shapes.
There you go. An orbit is the path a revolving object takes. We know orbits. Who remembers when you first learned about space? Aaron, how old are you?
10.
Like 10, well, you're 10 now. You've learned about space before now. So, how old were you when you first learned about space?
Oh, that's
Yeah, that's what I asked. What
um,
grade were you in?
like second grade.
Like 2nd grade. Some people may remember it like back in kindergarten. What did you learn about what the planets do? Zari.
They circle around the sun.
They circle around the sun. What's a science way of saying they circle around? Victoria.
They orbit around the sun.
They orbit around, or what's a science word that we've learned for that means circle around? Carla?
Rotate.
Not rotate. Rotate means spin. Cullen?
Revolution.
Revolution is when that happens, but what is the verb to mean circle around? You're close. Revolution is when that happens. But the verb, Smith?
Revolve.
Revolve. Remember, Carla, and everybody else, because I know other people probably thought it was rotate. Rotate means to spin in place. Revolve means to circle around another object. So, one of the first things you learned was that the planets circle around or revolve around the sun. And you learned that that path it took, you probably saw it like, here's the sun. Here's a planet. And so on. Like 8 more times. Or 8 times total. These little paths that it takes was the planet's orbit. So the path that the planets take around the sun is their orbit. Finish out that paragraph.
Earth's orbit is shaped like an ellipse or flattened circle.
We're not going to write that definition, but I want everybody to understand that an ellipse is a flattened circle. So what's another name for an ellipse? Kingston?
An oval or
An oval. An oval. An oval and ellipse are very similar. Well, we don't want to call it a circle because then we think of this. But an ellipse is a flattened circle, like an oval. Yes, Zadie, quickly.
And we learned about an ellipse in art when we were making, like, when we were shading.
Yes, art has a lot of shapes in it. Okay, keep going, Ethan. Read the last little bit.
Earth's orbit around the sun takes 36.5.
Oh, what's that word?
365.
In 1/4.
1/4 days or 1 year.
So, Earth's rotation takes how long? Smith.
300.
Earth's rotation takes how long? Carla.
It takes 24 hours.
It takes
Sun
24
to
hours.
time.
Earth's rotation takes 24 hours. I figured I'd trip somebody up on that. How long does Earth's revolution or orbit take? Zadie.
1 year.
About 1 year. 365 and 1/4 days. What do you think that 1/4 days causes? Think about it. Kingston? A leap year. Very good. I knew he got it. I could just see it. A leap year, because how often does a leap year happen? Smith?
Every 4 years.
Every 4 years. So in order to make sure that summertime stays like it is and wintertime stays the way it is, every 4 years we have to add a day to the calendar. Otherwise, eventually all the seasons would be all wrong. Okay, read next. Michaela, loud and slow.
Earth titles
Not titled. Cover up the ED. And what's that word?
tilt
Now add ED to the end.
is
So how do we say that?
tilted.
So read that, start that subtitle again.
Earth
Tilted,
tilted axis.
not access, but axis.
Axis. Earth's axis is not straight up and down.
So pause, go back to the diagram on page 360. You can see that the axis is not straight up and down. It's tilted. You see that, right? Okay, keep that in mind. Go back and keep reading.
It is tilted at an angle of 23.5
Degrees.
degrees.
Remember that little tiny circle means degrees.
The tilted point is the same
Go see.
direction throughout Earth's orbit.
That means as the Earth is orbiting, let me get the globe. As the Earth is orbiting, this tilt stays the same way. So pretend that, let me move this. It still spins, but the tilt doesn't change. I'm trying to make it stay the same. Do you see that? It doesn't tilt this way as it goes around. It stays like this. Okay? Does everybody understand what I'm trying to say? It's not going like this. Okay? Keep going, Michaela.
This tilt causes sunlight to strike Earth at different angles. At any time given, each
No.
hemisphere
Hemisphere.
or half of Earth gets more or less sunlight. The seasons result from both Earth's tilted axis and its revolution around the sun.
So, rotation, the Earth's rotation causes what? The Earth's rotation causes what? Victoria?
It causes day and
It causes day and night. The Earth's revolution causes what? Zari. Oh, you muted yourself right as you started. You were unmuted and then you muted yourself.
Can you hear me?
Yes.
It causes years.
Not years. Carla?
The 4 seasons.
It causes seasons. I said that at the beginning of the lesson. The Earth's rotation, spinning in place, causes day and night. Because as the Earth spins, it faces the sun, which means that part is in the daytime, and then it moves away from the sun, which means that part is in the nighttime. The revolution, how it moves around the sun, causes the seasons. Rotation causes what, class? Rotation causes what, class?
Day and night.
Rotation causes?
Day and night.
Rotation causes?
Day and night.
Rotation causes?
Day and night.
Revolution causes?
Seasons.
Revolution causes?
Season.
How? Well, read next. Zari. Oh. Carla, read next. Tell us how revolution causes seasons. And then we'll look at this diagram, hint, 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 at the bottom.
Four seasons. How does Earth's chills cause summer, fall, and spring?
Oh,
Cause summer, fall, spring, and winter. In June, the North Pole tilts towards the sun. Sunlight hit the north hemisphere at the steep edges.
angles.
Still angles.
Steep angles. Go slow, Carla.
Steep angles. The light is more than intense. It is summer.
So, pause. Let me show you what that means. Sadie, can you turn the lights off?
Do you want me to do the camera?
What?
The camera?
No, I think we'll be good. Okay. So, what Carla just read. In June. Let's see. Here's North America right here. Like I'm pointing to it. Here's the sun. North America, in its revolution, is closer to the sun than South America. Do you agree? I'll move it closer. North America, do you see? It's right here. Is closer to the sun than South America. Do you see? You can actually see North America. I mean, you can't see North America because it's so bright. You can see South America. Which part do you think is hotter? North America or South America? And why? Mason.
I think it's North America.
North America. Why do you think North America is hotter in June when it's closer to the sun like we can see right now? Who can help them out? Why is North America so hot right now in June? I kind of gave it away. Lena?
Because it's close to the equator. Closer to the equator.
Well, okay. But the equator is closer to what? Smith?
The equator's closer to South America.
Is South America always hot no matter what? Guys, what is North America closer to right now? than South America, or most of South America? Ethan.
The sun.
The sun. Where does all the heat that we have come from? Zadie.
The sun.
The sun. So right now, it is daytime in June in North America because the sun is facing North America and it's also closer. Now, it's nighttime in North America, but it's still summer because it's still closer to the sun than way down here, or even than down here. Zadie, please turn the lights back on. And Aaron, read next, loud and slow.
In December, the North Pole tilts away from the sun. Sunlight strikes the northern hemisphere at low angles. It is winter in the northern part of the world. In the southern hemisphere, however, it is summer.
So, what that looks like is, now, hold on, I think I can't hold, we're just going to have to look at this diagram for this because I can't hold this globe the correct way because of this. So, we're just going to have to look at the diagram. So, summer is caused when that hemisphere is closer to the sun, is pointed towards the sun. So, look at the part of the diagram where the earth is labeled summer. Do you see how the northern part of the world is closer to the sun than the southern part? Does everybody see that? The northern part, the top, is closer to the sun. Then we go to December. So move across. Do you see how the southern part, so now I'm the sun, here's the earth. The northern part is closer to me. So it's summer in the northern part. But now, 6 months later, in December, which part is closer to me? The southern or the northern? The bottom or the top? Lena?
The southern.
The southern part, the bottom. Do you see that? And then if you look at the diagram, you can see that too. In the summer, the northern hemisphere is closer to me. In the winter, the northern hemisphere is further from me. That's why if you were to go to Australia for Christmas, it'd be the middle of the summer there. Because look, right now, it's December. It's Christmas time in North America. It's facing away, it's tilting, not facing, but tilting away from me, right? So it's cold. But look at Australia. Australia's like right there. It's tilted towards me. So that's why the seasons in the southern and northern hemisphere are opposite. Because in the summer, when the northern hemisphere is tilted towards me, it's warm up north, but look at where the south is. It's colder. It's further away. It's like tilted that way. In the winter, it's cold where we are because it's tilted away. But look at the southern hemisphere below the equator. It's tilted towards me, so it's hot. So right now, it's spring in North America, in the northern hemisphere, which is what we see at the top. We're kind of moving towards being tilted towards, because we know summer's coming next. Follow the red arrows. Do you see spring? We're not all the way tilted towards the sun, But in the next season, we will be, right? So that means right now in North America, we're both kind of the similar place. We're not really towards it. Northern hemisphere isn't really tilted towards the earth or away. It's spring. What season is it in the southern hemisphere? Down here. Right now it's spring in the northern hemisphere. We're kind of not really tilted towards or away. Neither is the southern hemisphere. What season are they in? Colin.
Summer.
Summer? Are they tilted? Is the southern hemisphere tilted towards us, towards me, the sun right now?
Oh, no.
Is it tilted away?
Yes.
Look at where it is. I'm the sun. Here, it's very obvious. It's December. The southern hemisphere is tilted towards us. The northern hemisphere is tilted away. But what about right now? Is either one really any closer or further from me?
No.
So what season is it? If it's spring here, what is it there?
Spring.
Spring means summer's coming next. Are they about to be tilted towards, like us? Or are they about to be tilted away?
Tilted away.
So that means what season is it there?
Winter.
Winter is when it's totally tilted away. It's not tilted away right now. Who can help her out? Zadie.
It's fall.
It's fall. Look. Look at the diagram. Spring, we're both kind of tilted similarly. Here's spring. Neither one's really tilted towards or away because we're kind of tilted the northern hemisphere is tilted like that direction where there's nothing. And the southern hemisphere is tilted that direction where there's nothing. But what is coming next for us? Summer or winter? Victoria.
Summer.
Which means what is coming next for the southern hemisphere? Michaela.
Winter.
Winter. What season comes before summer? Lena.
Spring.
So right now, what season is it in the northern hemisphere?
Fall.
Look at where we are. And think about what's coming next. In the northern hemisphere, what's coming next?
Summer.
Look at this. In the northern hemisphere, what's coming next? Look at this.
Winter.
In the northern hemisphere, what's coming next? Why are you looking at your book? I have it right here. Right now, is the northern hemisphere or the southern hemisphere pointed towards the sun? Me.
No.
No, neither. What's pointed towards me? The sun now.
North.
The northern hemisphere. Which means, what's coming next? Look at the movement of this globe. Here's where we are. What's coming next? Summer or winter?
Winter.
Where is the northern hemisphere? I'm the sun.
Summer.
Okay, now I think you're just guessing. Who can help her out? Stop looking at your book. I have the demonstration right here. This is literally the earth. Do you see how the axis is not moving around me? I would continue to move it behind my body, but my arms do not move like that. Right now is where we are. This is the direction that the earth is moving. What is coming next? Smith,
Summer.
how do you know?
Because the northern hemisphere is facing the sun.
It's tilted, not facing, because facing is like this. It's tilted towards the sun, which is me. When the hemisphere is tilted towards the sun, that means it's warmer, so it is summer. So right now, when it's this, the northern hemisphere is tilted that way, where there's nothing. The southern hemisphere is tilted this way, where there's nothing. Are either of them tilted towards me, the sun? But what will the northern hemisphere be in next? Zari. hear what you said. Guys, but I can already tell that you mouthed fall, which is not correct. Carla, you're not even listening. You're watching TV or what's going on in the background. Listen. Focus. Dog ear this page and close the book. Nope, I need to do that. It's too low. Here's the earth. I am the sun. I am going to be spinning, but imagine that I'm not because my arms won't move behind my body. Okay? Look at what is happening. Wait, I don't think I can do it because... Okay, somebody else come be the sun. I'll pick a stick. Mason's not here. That's me. Kingston, come be the sun. So just stand. Does the sun move? Nope, so you're just gonna stand in one place right here. I would let you use the flashlight, but then it won't be all the way around. So come stand exactly where I am and don't move. Okay, Kingston's the sun. Here's the earth. Imagine that I am one, here, scoot that way just a little bit. Imagine that I am also part of the earth, okay? Like, pretend I'm not here, okay? Do you see how the earth is spinning while this is happening, but the axis is not moving? Can you scoot up just a little bit? Do you see this? The axis is not moving. It is tilted the same way. The earth is spinning. I think I'm spinning it in the wrong direction, but oh well. But it is also revolving. Right now, is it is the northern hemisphere, Kingston is the sun, is the northern hemisphere in the summer, winter, spring, or fall? Aaron. Winter, why? It's pointing away from the sun. The top of this earth is tilted away from the sun. What season is it in the southern hemisphere? Carla. What season is it in the southern hemisphere?
Right now, it is.
Look at the globe. I'm doing a demonstration, but I think you missed most of the demonstration. Kingston is the sun. The earth is the earth. What season is it right now in the southern hemisphere? Michaela, help her out.
It's summer.
Summer. Why is it summer?
Because the southern is closer to the sun.
The bottom of the earth, the southern hemisphere, is closer to the sun. Right now. Nope, you're staying there because you're the sun. The sun is still here. What season is it in the southern hemisphere? I'm sorry, the northern hemisphere. It's winter. Now I'm here. What season is it? Smith.
Spring.
Why is it spring?
Because both ends are kind of in the same way.
So neither the northern or the southern, neither of them is tilted towards the sun. But why is it spring in the northern hemisphere? What just happened?
You came from winter.
I came from winter. What season always comes after winter, class?
Spring.
Spring. That means it was just summer in the southern hemisphere. It's not tilted away or towards the sun, so what season is it in the southern hemisphere? Mason, are you raising your hand? Okay, I need you to participate, please. Cullen.
Spring.
What season was it just in the southern hemisphere?
Summer.
So what season is it now? Is it tilted towards or away from the sun?
No.
What season? It was just summer. What always comes after summer?
Fall.
Fall. Sorry. It's winter in the northern hemisphere, summer in the southern hemisphere. Neither is tilted away. Winter just ended in the northern hemisphere, so now it's spring. Summer just ended in the southern hemisphere, so now it's fall. What season is it in the northern hemisphere now? Zari.
Winter.
Michaela.
Summer.
Summer. Why is it summer in the northern hemisphere right now?
Because now the northern is facing the sun.
Because now the northern part, the top of the globe, is facing the sun. What season is it in the southern hemisphere? Lena.
Winter.
Winter. Why?
Because it's pointing away from the sun.
Because the southern hemisphere, the bottom of the globe, is pointing away from the sun. What season is it in the northern hemisphere? Victoria.
Fall.
Fall. Why?
Because
There's two reasons why.
the northern hemisphere is. I mean, I know why, but I don't really know.
Who can help her out with why? She is right. It is currently fall in the northern hemisphere. There are two reasons why. The first reason is the same as why this is spring. Zadie.
Because it's not really pointing away, but it's not really like pointing towards.
Good. Yes, I'm sorry. I was doing this because I was agreeing with you. It's not. It's not tilting. Yes, but I realized that might have made you think I was saying you're wrong. No, yes, correct. It is not. It is fall because it's not, the northern hemisphere is not really pointed towards or away. But why is it fall and not spring, Zadie?
Because it was just summer.
Good, because it was just summer. What comes after summer, Zadie?
After summer, it's fall.
Good. When we were here, it was winter in the southern hemisphere because the southern hemisphere was pointed away. What is the season now in the southern hemisphere? And why? Come on, guys, it's patterns. It's all patterns. Science and math are all patterns. Michaela.
It's fall.
It's fall. Wait, nope, it's not fall. It's fall in the northern hemisphere. What season is it in the southern hemisphere? And you have to tell me why. I know some of you know what it has to be because it's the only option left. But if you can't tell me why, put your hand down right now. Because I'm not interested in you just giving me an answer just because you want to be right. I want to know that you know why. It's the same reason. It is now, what season is it in the southern hemisphere and why? Lena?
Spring.
Spring, because there's two reasons. The first reason is exactly the same.
Because I'm trying to put towards it. I know the reason.
Hey, who can help her out? Colin.
Spring because it is pointing away from the sun.
Nope. It is winter when a hemisphere is pointing away from the sun, no matter what. Whether it's here, it's winter in the southern hemisphere because the southern hemisphere is pointing away from the sun. It is winter in the northern hemisphere because the northern hemisphere is pointing away from the sun. Is the northern or southern hemisphere pointing away from the sun right now?
No.
No. Smith.
Because we just came from winter.
Okay, so that's one reason. Well, that's one reason that the southern hemisphere is now in spring. It was just winter. The southern hemisphere was pointing away. What season always comes after winter, class?
Spring.
But what's another reason that it's spring and not summer or winter? We know it's spring because we just came from summer. I'm sorry, we just came from... So yes, that is why we know that it's spring because we just came from winter. But why else do we know that it's spring and not summer or winter? Zadie.
Because it's not pointing away, but it's not pointing towards.
It's not pointing away or towards. Both hemispheres are the same distance from the sun. So let's recap. Right now, the northern hemisphere is pointed away from the sun. Remember, Kingston is the sun. The northern hemisphere is pointed away from the sun. So in the northern hemisphere, it is now what, class?
Winter.
Winter. The southern hemisphere is pointed towards the sun. So right now, it is what season in the southern hemisphere, class?
Summer.
Summer. Right now, neither hemisphere is pointed away or towards the sun. The northern hemisphere just left winter. So it is now what season in the northern hemisphere, class?
Spring.
Spring. The southern hemisphere is not pointed towards or away from the sun, and we just left summer. So it is now what season in the southern hemisphere, class?
Fall.
Fall. Now, the northern hemisphere is pointed towards the sun. So it is what season in the northern hemisphere, class?
Summer.
The southern hemisphere is pointed away from the sun. So it is now what season in the southern hemisphere, class? Winter. The northern hemisphere is not pointed away or towards the sun, and we just left summer. So it is now what season, class?
Fall.
Fall. The southern hemisphere is not pointed towards or away from the sun. We just left winter. So it is now what in the southern hemisphere, class? Spring. Remember, whatever season it is in the northern hemisphere, it's the opposite in the southern hemisphere. What is the opposite of winter, class?
Summer.
Summer. What is the opposite of summer, class?
Winter.
What is the opposite of spring, class?
Fall.
What is the opposite of fall, class?
Spring.
So if it is spring right now in the northern hemisphere, thank you, son. What season is it right now in the southern hemisphere? Right now, literally, at this time in March, on March 23rd, 2021. What season is it in the southern hemisphere? Zari.
Spring.
Michaela.
Fall.
Fall. Why is it fall in the southern hemisphere right now?
Because you just said whichever is the opposite of what it is in the northern.
Good, because I just said whatever season it is in the northern hemisphere, it is the opposite in the southern hemisphere. We live in the northern hemisphere. What season is it right now, Zari?
Spring.
Spring. What is the opposite of spring, Zari?
Fall.
Fall. So one more time. Whatever season it is in the northern hemisphere, it is the opposite in the southern hemisphere. It is spring in the northern hemisphere. That's where we are. That means it is fall in the southern hemisphere. Zari, stop messing with it. Okay, now it's June. What season is June in? Well, let's say July. What season is July in the northern hemisphere, where we are? July is in... Come on, guys. This is like you learned this in kindergarten. Zadie.
Summer.
Summer. So it's June. What season is it in the southern hemisphere? Colin?
Winter.
Winter. Okay, now it's November. November is in what season? Aaron.
Winter.
November is in what season? Victoria.
Fall.
Fall. What season is it in the southern hemisphere in November? Spring. It's December. Well, no, it's January. What season is January in where we are? Michaela.
Winter.
Winter. What season is it in January in the southern hemisphere?
Summer.
Summer. Very good. Okay. So, and then we see some seasons. However, it is completely opposite for the southern hemisphere. So, Let's look at this diagram. Summer is from June 21st to September 22nd in the northern hemisphere. We're back on where you put your dog ear. Quick, quick, quick. But what season is June 21st to September 22nd in Australia in the southern hemisphere? Look at it. Summer is from June 21st to September 22nd. But in the southern hemisphere, what season goes from June 21st to September 22nd? Smith.
Winter.
Winter. Here in the northern hemisphere, fall is from September 22nd to December 21st. But what season is that in the southern hemisphere? Aaron. Spring. Here in the northern hemisphere, winter is from December 21st to March 20th. But what season is that in the southern hemisphere? Carla.
Fall.
Smith.
Summer.
Summer. In the northern hemisphere, spring is from March 20th to June 21st. What season is that in the southern hemisphere? Cullen.
Fall.
Fall. Remember, one more time, whatever season it is in the northern hemisphere, it is the opposite season in the southern hemisphere. Summer and winter are opposites. They are completely different. Spring and fall are opposites. Spring and summer are not opposites. Fall and winter are not opposites. Fall, whatever, I think I would just say the same thing. Winter and summer are opposites. Fall and spring are opposites. So look at this diagram one more time, because hopefully you will all get a 100 on this independent practice. Look at spring. Neither one is really pointed towards or away, but follow the arrow and what's coming next. Cullen. Summer, where the northern hemisphere is pointed towards the sun. Then if we follow the arrow again, we see the earth is not really pointed in any direction, but what's coming next? Lena.
Fall.
Fall. Then we follow it and we go to the next. The northern hemisphere is pointed away. What season is it? Zadie.
Winter.
Winter. But remember, in this top earth, the earth on the top, what season is it in the southern hemisphere? The earth on top, what season is it in the southern hemisphere? Michaela. Fall. The bottom earth, what season is it in the southern hemisphere? Lena.
Spring.
Spring. The left earth, the one this way on your book, what season is it in the southern hemisphere? Carla.
Summer.
That's what it says, the northern. Carla, please listen. You've got to stop watching the TV. Zadie.
Winter.
Winter. The right earth. What season is it in the southern hemisphere? Aaron. Summer. We can look at these pictures and we can see that the northern hemisphere is pointed towards the sun in summer. The northern hemisphere is pointed away from the sun in winter. So we know these labels on this diagram are for which hemisphere? The northern or the southern hemisphere? Smith.
The northern.
The northern, because whatever the northern direction is pointing, well, yeah, that's the season it says. When the northern hemisphere is closer to the sun, it says summer. When the southern hemisphere is when the northern hemisphere is further from the sun, it says winter. So that means whatever this diagram says, it's the opposite in the southern hemisphere. Okay. Let's read the last page, page 364. I hope some of you just tuned out. Some of you just let the fact that you tuned out at one point and missed a whole part and then couldn't understand the rest. Instead of trying to catch up, you just kept thinking, what? Aaron, please read on page 364, loud and slow.
How does the sun's apparent path change over the season? The diagram shows the apparent path of the sun during the day.
Pause. Apparent path. Does that mean the actual real life path? What does that mean? Apparent path means what? Lena.
Like an imaginary one?
Not an imaginary. Apparent path. Come on, we talked about this yesterday. We even had a vocab word. Zadie.
The way it appears.
The way it appears. Is the way it appears the way it actually is, Zadie?
No.
No, not necessarily. Not when we're talking about space. So does the sun actually have a path that it travels? No, it just looks like it. Keep going, Aaron.
Each yellow circle represents the sun's position at noon. How does that position change from winter to summer? The sun rises much higher in the sky during a summer day. It also rises earlier and sets later.
So if we look at this diagram at the bottom, that yellow circle, this is the sun. It represents the sun at noon, at 12 p.m., right when we go outside for recess. Look how in the summer, it's really high in the sky. But in the winter, it's really low in the sky. And in the spring and fall, it's kind of in the middle. That's again because, Kingston, come be the sun one more time. Come on, quick. During the summer, the sun is closer, so it appears higher. But during the winter, the sun is further, so it appears lower. No, stay standing. So it appears lower, because look at where the sun is now. It's much lower, right? But where the sun is now is much higher. It's towards the top, like towards the pole. Here, it's towards the equator. And in the spring, it hits in pretty much the same place as the fall, right in the middle of the equator and the pole. That's why. Thank you. Go ahead and have a seat. Thank you, Aaron. Please read next. Smith.
At the equator, the diagram does not apply to all parts of the world. Near the equator, the sun's apparent path changes much less during the year. Temperatures there change little from season to season. All year long, sunlight strikes at similar angles.
Let's look at that. Kingston? I'm not going to rotate. Well, I guess I can rotate it. Okay, stand kind of right in the middle. Look at how the equator is still really close to the sun the whole time. Do you see how the equator really doesn't move much further? Or please don't do that because then I can't go around. Much further away, no matter what. It's kind of always at the same place. It's just the tops and the bottoms of the earth that moves. So that means the seasons don't change much at the equator. Where the sun rises and sets, or the apparent motion across the sky doesn't really change. Because the equator is pretty much always the same angle from the sun. Well, what about at the poles? Victoria.
At the poles, near the poles, the sun's apparent path is very different between seasons. In northern Alaska, for instance, summer nights are very hot.
Nope, that's not what it says.
In northern Alaska, for instance, summer nights are very short. During winter, the sun hardly ever appears.
Let's demonstrate. Kingston, come be the sun. Alaska is right here. So I'm going to put a post-it. Now it's much bigger than Alaska. But look how during the summer, Alaska is mostly facing the sun like all the time. Because look, even when it's like way up here, look at where the sun is. The sun is pretty much still shining on Alaska. Do you see that? But in the winter, look at how the sun, here, scoot that way a little bit. In the winter, look at how the sun is almost never on Alaska. Because even here, stop, Mason. Even here, look at how the sun is like lower than where Alaska is. So in the winter, in Alaska, nighttime can be like 20 hours, 22 hours of the day. It's dark. But then in the summer, it's light for like 22 hours. That's because of how close it is, the northern hemisphere, or the North Pole is in the summer, and how far the North Pole is in the winter. So would you want to live in Alaska in the winter? Would you really want to live in the summer either and it be bright all the time? No. But some people live there. Okay, thank you. Go have a seat. Yes, what is your question?
Really quick. So they get like 4 hours of sleep in the
Well, they just make it so that like they have like really strong curtains that you can buy so that you can make it all the light go away. But yeah, they do have to do things like that so that they can sleep longer. Quickly, Smith.
During the winter, or since it's winter most of the time in Alaska, you don't really see the sun.
Well, no, it's not winter most of the time. They still have the same seasons as us. But during their winter, when they're tilted away, they just really don't get any sun at all. And during their summer, when they're tilted towards, they don't really get much darkness. But in the winter, it is dark most of the time. It's not winter most of the time, it's dark most of the time.
And that's why they don't see the sun except for like 2 months.
Yes. Okay. Read the last paragraph. Ethan.
Making predictions. The sun's apparent path changes in the same pattern every year. Scientists use these patterns to make predictions. They can predict the exact times the sun will rise and set.
Good. Does the Earth's orbit change? Does the path the sun takes around, does the path the Earth takes around the sun change? Does it change shapes? Does it change directions? Does it all of a sudden just do random little squiggles? Or does it just stay like this all the time, forever and ever? It just stays. So that's why we know that summer's going to happen those certain days. That's why we know pretty much what time the sun will set on a certain day in the winter. Because it never changes positions. It never changes directions. It never changes paths. It stays the same. Patterns, patterns, patterns. Okay, so now, hope that you were paying attention and you didn't let the fact that you maybe zoned out for a second confuse you the rest of the time. Those of you at home, go ahead and get out yesterday's independent practice because we're going to do the back today. It's the one that says what causes seasons. And it has the diagram on page 362. Yes, that's it. We've seen this before. Where have we seen this diagram? Ethan? Page 362. So I would probably go ahead and write page 362. And then remember, same as the front, you're going to answer these questions using both the diagram and the words, potentially the words written around the diagram in the book. That's why it helps to have that page number written so that you know, well, any information that's not on this diagram is probably going to be around that page in the book. Make sure that you are keeping in mind the fact that this sheet is about seasons, not day and night. Any questions? Victoria?
Do we have to write in?
Same rule as yesterday when it comes to sentences. You do not have to write in complete sentences, but if you do and you are very close to the next letter grade, I might be like, well, they put in a lot of effort, so I'll go ahead and move them up to that next letter grade. If not, nope, you get what you get. Does everybody understand? Okay, go ahead. We are going, let's see, it is 2:09. At 2:45, we will start packing up. That means work on this first. If you finish, you may work on math independent practice, reading independent practice, or grammar independent practice from yesterday. Any questions? You do have science homework. It is the outline for this lesson. It is due tomorrow. I'll go ahead and pass that out, and that can go right into your return to school.